Welcome, everyone. If you're ready to move beyond browser-based AI chats and start building production-grade AI applications, you are in the right place. Today, we are mastering the technical infrastructure required to seamlessly integrate Claude into your existing software stack. Let's start by defining what we mean by AI technical infrastructure. When we build with Claude, we aren't just making simple web requests, we are orchestrating complex, stateful systems. The absolute basics involve getting your API keys, setting up local development folders, and pulling in the right software development kits, or SDKs. Why is this so critical? Because treating an LLM integration like a basic third-party widget leads to massive security vulnerabilities and unscalable code. How do we do it right? We start by strictly isolating our credentials and standardizing our development environments. In our deep dive, you'll see that true enterprise AI infrastructure requires thinking about LLM gateways, token monitoring, and advanced tool orchestration using the Model Context Protocol. Take a look at this high-level architecture diagram. It maps the journey of a prompt. It starts on your local machine, securely pulling credentials from environment variables. The request is formatted by the client SDK and pushed out. Notice the routing node, an LLM gateway. In enterprise setups, your request might not go straight to the Claude API. It might be securely routed to Claude hosted on Amazon Bedrock or Google Vertex AI, allowing you to use existing cloud agreements. Before we write a single line of logic, we must secure the perimeter. Your API key is your credit card. The basics of security dictate that you generate your key in the Anthropic console and keep it fiercely guarded. Why am I stressing this? Because the number one mistake new developers make is hard-coding keys into their scripts. If you push that to GitHub, malicious bots will scrape it and rack up thousands of dollars in charges in minutes. How do we protect it? We use environment variables. You store your key in a hidden .env file locally, and you immediately add .env to your .gitignore file so it never leaves your machine. For our deep dive, know that at the enterprise level, you might not use keys at all. You might use cloud-native IAM roles to authenticate directly to Bedrock or Vertex AI seamlessly. This sequence diagram illustrates the secure credential lifecycle. You, the developer, save your secret key strictly into the local .env file. When you push your work to GitHub, the Git protocol completely ignores the .env file. Meanwhile, your app code reads the key directly from the local file system at runtime. This creates an airtight seal around your credentials, keeping your project both collaborative and secure. With our keys secured, we build our coding environment. The what here is the client SDK. Instead of writing messy, manual HTTP requests using curl or fetch, we use Anthropic's official libraries. The basics involve installing the SDK for either Python or TypeScript. Why use the SDK? Because it's engineered for resilience. The SDK automatically handles connection timeouts, implements exponential backoff for rate limit errors, and manages complex streaming protocols for you. How do you set it up? Always isolate your dependencies. In Python, spin up a virtual environment and pip install Anthropic. For our deep dive, TypeScript developers must pay attention to their compiler configuration. Set your config.json to target ES 2022 and use Node.next module resolution. AI libraries heavily utilize modern JavaScript features like top-level await, and improper config will break your build immediately. This mind map breaks down your SDK setup paths. Branching to the top, we see the Python route emphasizing virtual environments and pip installations. Branching below is the TypeScript route, highlighting NPM package management and the crucial ES 2022 compiler target. Both paths converge on the core benefits on the bottom right, getting automatic retries, strict type safety, and seamless streaming support right out of the box. It is time to write some code and make our first API call using the Messages API. This is the heart of Claude. The basics require you to specify three things: the exact model version you want to use, a maximum token limit to control costs, and your array of messages. Why the Messages API? Because it is the unified gateway. Whether you are sending a simple text question, analyzing a PDF, or triggering an external tool, it all routes through this exact same endpoint. Look closely at the sample code on the slide. You instantiate the client, define the Sonnet model, and pass your user message. For the deep dive, notice a critical security feature. The system prompt is passed as a separate top-level parameter, completely outside the user messages array. This strict separation isolates your application's core rules from user input, forming your first line of defense against prompt injection attacks. Observe the data flow in this architecture diagram. Inside your application code, you have two distinct streams. The red node represents your system prompt, your hard-coded developer rules. The blue node represents untrusted user input. The Messages API builder cleanly packages these together, but keeps them logically separated. This payload is posted to Anthropic servers, which processes the instructions safely and returns the JSON response to your app. As you move from a solo developer to an enterprise team, direct API connections don't scale. Enter the LLM gateway. What is it? A centralized proxy server that intercepts your AI traffic. The basics are simple. Instead of pointing your SDK to Anthropic's public servers, you point it to your internal gateway. Why is this necessary? Because managing dozens of raw API keys across a company is a security nightmare. Gateways allow IT to centralize authentication, enforce dollar budgets, and track exactly which team is spending what. How do you do it? You simply override the base URL parameter when initializing your SDK client. Our deep dive reveals the true magic of gateways, fallback routing. If the primary Anthropic API experiences a network blip, a smart gateway like Lite LLM can instantly reroute your exact same prompt to a Claude instance hosted on AWS Bedrock, ensuring zero downtime for your users. This flowchart demonstrates enterprise scale. We have 3 different internal apps: marketing, support, and engineering, all routing their requests to the central yellow node, the internal LLM gateway. The gateway acts as a traffic cup. Its primary route is sending requests directly to the Anthropic Claude API. But look at the dotted failover lines. If the primary route degrades, the gateway automatically shifts traffic to AWS Bedrock or GCP Vertex, maintaining perfect uptime. To make Claude truly powerful, it needs to access your internal data. We achieve this using the Model Context Protocol, or MCP. What is MCP? It is an open-source standard designed to connect AI models to external tools seamlessly. The basics rely on a client-server architecture. Your app is the client, and your database runs an MCP server. Why did the industry create this? To solve the N times M integration problem. In the past, you had to write custom glue code for every single tool. With MCP, you write the server once, and any MCP-compatible AI can query it. How do you connect? You can run the server locally using standard input, output, or remotely over HTTP. For the deep dive, understand that this happens dynamically. When your client connects, it performs a handshake, dynamically discovers all the tools the server offers, and automatically translates them into schemas that Claude instantly understands. This architecture diagram showcases the elegance of MCP. On the left, your AI client app communicates securely using JSON RPC protocol over to the central MCP server. This server acts as a universal translator. It handles the specific, messy API connections to the PostgreSQL database, Slack, and GitHub on the right. Your AI client never needs to know how Slack's API works. It just asks the MCP server to send a message. Let's apply this in a real-time use case, building an intelligent database analyst. Imagine you want an AI that can safely query your live SQL database to answer team questions. Step 1. You spin up an MCP database server locally, which exposes your database safely as a set of tools. Step 2. You initialize your Node or Python client with the Claude SDK, applying a strict system prompt declaring Claude as a SQL expert. Step 3 is the Agentic loop. The user asks, "How many active users do we have?" Claude processes this and outputs a tool use request. Step 4. Your client infrastructure intercepts this, securely passes the query to the MCP server, gets the raw database rows, and feeds them back to Claude to synthesize a human-readable answer. A highly helpful technical detail: always wrap this execution in a try/catch block. If Claude writes bad SQL, catch the error and send the error text back to Claude. It will actually read the error, correct its own SQL syntax, and try again automatically. Follow the agentic loop in this state diagram. We start with the user prompt going to the Claude API. Claude responds with a tool use stop reason, shifting the state to the MCP server. If the query works, we hit tool success. If it fails, we hit tool error. Crucially, both paths loop right back into the Claude API, allowing the model to either synthesize the success data or autocorrect the error, looping until it achieves a final response. As we finalize our infrastructure, we must enforce security guardrails and data privacy. The biggest concern enterprises have is data leakage. Rest assured, Anthropic provides zero data retention, ZDR, for commercial API users. Your proprietary data is never stored and never used to train their foundational models. Furthermore, if you route your traffic through AWS Bedrock or Google Vertex AI, your AI requests automatically inherit your company's existing compliance frameworks, like HIPAA or SOC 2. Defend against prompt injection by utilizing strict data separation. Always keep user input quarantined inside XML tags, far away from your system prompt. Finally, practice the principle of least privilege with your tools. Never give an MCP database server write or delete access if it only needs to read data. Building robust infrastructure means balancing incredible AI autonomy with ironclad security. If you found this technical deep dive valuable, please like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. Thank you for building with us. Our final diagram is a mind map summarizing our AI security posture. Branching from the center, we have data privacy, emphasizing zero data retention and the guarantee of no model training. To the right, access control focuses on using IAM roles and applying least privilege to all tools. Finally, threat mitigation covers the tactical defenses, strict prompt separation, XML tagging, and continuous input sanitization to protect your infrastructure.